So I'm Marty Knight. I am an associate professor in teaching and learning in the College of Ed and also a core faculty member in the Center for STEM Teaching and Learning. And I am really excited to introduce our speaker today, who's been brought here by the Center for STEM Teaching and Learning and the Department of Applied Physics and Materials Science. So a joint thing. So this is Dr. Dusen from Iowa State University. He is an associate professor of science education, and he has 3 intertwined strands of research. So he looks at STEM education assessment as the director of the Lasso platform, which is an online tool to support STEM instructors in making empirically grounded pedagogical decisions. He investigates issues of equity in STEM student outcomes and looks at the critical examination of quantitative research methodologies. I've known Ben for a while. We were Einstein Fellows together when we were teachers before we went back and got our PhDs, and he's one of my favorite people. And so I'm really excited to welcome him to NAU, and I have a little NAU mug.
Thank you.
NAU Teach swag. And so I think this will be a great presentation.
Great, thank you so much. Yeah, thank you for all coming to my talk today. That was a great introduction, and all 3 of those threads are things that that I do. All of them you'll get to see here today. So I'm going to start off with a little background on what I'm about. So I'm a former high school physics teacher, part of where I met Marty. I'm also now a discipline-based education researcher, and so to be a discipline-based education researcher, that's kind of a fancy way of saying like a science education researcher. My disciplinary expertise is physics, but I branch into the other STEM disciplines as well. And I'm also a critical quantitative scholar. And so what that means is, if I boil it down, there's kind of 2 things. I've got an affinity for numbers and statistics. I enjoy working with those things. And also, I believe that inequity is a central issue in our society and in my research. That's a focus of mine. And so if I were to draw like a little Venn diagram of where my work is situated, I've got some data science side, I've got critical theory, and then this discipline-based education research, and thinking about how we learn science, how we learn physics, is kind of where I situate myself. So then the other part about me that'll come into this research is I'm also the director of the Lasso platform. This is the online assessment platform that the data that you're going to see today comes from, and I'll chat just a little bit about that. But Lasso is a free online assessment platform for instructors to give pre-tests and post-tests to see how much their students learned or changed over the course of a semester. So what does this talk about? Right, there's 3 parts to this talk. The first part is going to be introducing and applying an emergent conceptual framework. Then part 2 is going to actually answer some research questions about inequity and science student outcomes. And then part 3 is going to be offering a tool to potentially help ameliorate these inequities. So, right, part 1 is introduce and apply this emergent conceptual framework. I'm going to throw something out there. I'll be surprised if anybody has. Does anybody know what strategic positivism is by any chance? Even in education, it's a little more esoteric. So don't feel bad. I'll give you a little overview. So it actually comes from critical geography scholars. And the background here is that positivistic epistemologies, quantitative methodologies, and repressive political ideologies have often been entwined. And so some examples are folks like Fisher, Galton, and Pearson. These are like the forefathers of statistical methods, especially in the social sciences. They were all eugenicists, and they actually created these methods largely to support the eugenics movement. So this is where you see these repressive political ideologies getting entwined with some quantitative methodology, right? This is like the basics of a lot of statistics. And so this has led a lot of equity research to say, I reject that entire area. I'm going to go do qualitative research. I don't want anything to do with these tainted methods. I, however, as a strategic positivist, say, I'm going to be strategic in my use of these. I'm not going to turn them down. And I think we need to use every tool at our disposal to fight inequity. And these statistical methods are tools that we have. And so we need to be thoughtful about how we do it. But I think statistics can tell a compelling story. If you want to move politicians, if you want to move teachers, if you want to move anybody, a lot of times having a narrative, a qualitative narrative is helpful, but so are having the statistics to back up your argument. So I use all of these tools to try and create a more equitable society. So one of the tools that I like to draw on is called quantitative critical race theory. And so it's grounded in critical race theory, which has traditionally been a qualitative, associated with qualitative methods. But it's taking those same ideals and thinking, how do we translate them into quantitative research? So the focus traditionally with critical race theory is looking specifically at race and racism. But I'm going to expand this to look at other forms of oppression as well. This is how I'm choosing to use the tool slightly differently. We're going to go beyond race and racism. But something I really like about it is it offers some tenets to help guide research. And I find these to be really helpful. And so I'm going to share 6 of these tenets. Different people have offered slightly different tenets. These are the ways that we've chosen to define them in our work. But the 6 tenets are, first, the centrality of oppression. And so you notice I put a little square next to this, by the way. I'm going to be kind of tracking throughout the talk, like, oh, here's where this tenet informed my research. So I'll have, the little square, and it'll say the centrality of oppression. So that'll help you see how my conceptual framework is informing my research and our methods. But the idea of centrality of oppression is that racism and other forms of oppression exist throughout our society. This is an assumption I make in the work. It's grounded in all sorts of research, but I'm not going to try and support this claim with additional data. I'm going to say this is a starting place. I know this to be true in my work. And so it is incumbent upon me as a researcher to explicitly challenge these existing power structures. And it's my job to make the world a better place. Number 2, the data and methods are not neutral. We often like to think, especially with quantitative methods, like, oh, it's just the facts, just the data, it speaks for itself. But I disagree with that. All methods introduce bias. It's easy to point where qualitative methods like, oh, but you made all these decisions, it's just through your perspective. Like, that's true. But as quantitative researchers, we make lots of decisions too. We tend to hide those and pretend like, no, this is just the way stats is done. But there are many decisions we get to make, and they all introduce bias. And so I think a researcher needs to be conscientious about the decisions they make, what biases are they introducing, and then be transparent in their publications and in their talks. Number 3, data doesn't speak for itself. It cannot. If we say data speaks for itself, if we leave it to speak for itself, it will be interpreted through the dominant perspective. And as our first point said, the dominant perspective is an oppressive perspective. So if we do that, and let's say we see a difference in groups, that's probably going to lead to people saying, oh, there's this gap, there's this deficit, there's something wrong with these students. And I don't want my work to ever support that. I don't want to support a deficit narrative. So it's my job to speak for the data and make sure that it's telling the story that I believe it tells. 4th tenet is that categories are neither natural nor inherent. So social identities, things like my gender, my race. Right now, I've got like my researcher hat on. When I go home, I've got like I'm a dad hat. I've got all these parts of my personality, but they're all socially constructed and dynamic. In different situations, identify in different ways, so they're fluid. But to do statistics, we are going to have to create categories to be able to run, to create variables and create models. We just want to be really thoughtful about that and be careful we're not putting people where they don't want to be or leading to bad interpretations. So there's a tension between doing statistical work and wanting to represent people as the human beings that they are. So it's something we have to do, but we want to be thoughtful about. 5th, taking an intersectional perspective. So inequalities, right, are generated through interlocking systems of privilege and oppression. Some examples of those are racism, classism, and sexism. And when we think about the models we create, taking intersectional perspective pushes back on the additive approach. So the classic example of this is when we think about the ways that Black women experience anti-Black racism, that's going to be different than the way that Black men experience it. And we think about the way that Black women experience sexism, that's going to be different than the ways that white women experience sexism. That there's something unique about being a Black woman, that you're going to experience these things in different ways. So these are dynamic interacting systems. And so we can't just assume like, oh, if I measure the impact of sexism on white women and I measure the impact of anti-Black racism on Black men, if I add those two things together, I don't necessarily get the impacts on Black women. I'm going to need to actually look at how is that group being served in these situations. So we need to create a little more complicated models to allow it to do that, but we can do that. Sixth, value in narrative and counter narrative. And this is the idea that voices and insights are vital to eschewing racist assumptions, interpretations, and logics. And then we need to include marginalized and oppressed insights in this. So these are the 6 tenets of quant crit that are driving my work. But just a moment, any questions about these before we go on? We'll see them in action, which will hopefully help as well. But also, if you have questions along the way, don't feel like you have to hold them all to the end, right? Because then, like, oh, we've forgotten about slide 6. We're on slide 30 now. So please ask them as we go if you would like. So why am I spending this time to focus on theory? There's a couple reasons. First, quant crit is an emergent theory. It's being taken up by scholars now, but a decade ago, you would be pretty hard pressed to find anybody who was doing it. And so there's not a lot of guidance out there on how to do it. A lot of people are thinking like, oh, it's just a way to interpret your findings. But there's a lot of work still to be done to think about, no, really every step of your research should be informed by your theoretical perspective. And so I want to highlight these connections in this work to make it really clear how it can be used. And these are not answers. This isn't like how quant crit has to be done. It's what we figured out so far. And it's changing all the time. We're continuing to refine in our research group how we use it. And in fact, even some of the things I'm going to share today are already dated. Like I would do it differently if I were to do it again. But I think it gives some pretty good ideas. So where does theory inform research? So here's a bunch of different methods, all of which I can explicitly point to critical theory, quantitative crit, and our tenets and how they inform. We're not gonna have time today to talk about all of them. I do have slides for all of them. We're gonna about half of them in our slides today. So we also have time to look at the findings. Yeah, today's research. What are we gonna be applying these to get at is this study, which we titled The Quant Crit Analysis of Society's Educational Debts in Chemistry, Biology, and Physics Across Race, Gender, and Class. Our research team is myself, Jason Nissen, and Otis Johnson. And so first place that our tenets come in here is value narrative and counter narrative. Who are we? What perspectives do we bring to this work? So our positionality statements, we tried to bring forth the parts of our identities that tie to the things we're measuring here. There's many parts of our personalities we don't talk about here. But myself, I'm a continuing generation white cisgendered man with a PhD in education. Jason is a first-gen white cisgendered man with a PhD in physics. And Otis is a first-generation cisgendered gay Black male with a PhD in education and social policy. So these are some of the perspectives we bring to this work. All right. So our data collection. This is, we come back to Lasso. This is that online assessment platform I was talking about. We've got a bunch of NSF grants to help make this free for faculty. But the idea is it's an easy way for faculty to measure change in their students, whether that's their conceptual learning, their identities, their self-efficacy. It's been used by over 130 different institutions, over 80,000 students, bunch of courses, mostly looking at STEM disciplines in colleges. So the kind of intro college courses tends to be what it focuses on. So we have all this data, which is great, but we have to remember our data and methods are not neutral. So think about, okay, what bias might already exist in this data set? And so when we looked at it, the important, or one important place we saw bias is the people who choose to use Lasso are not necessarily your typical instructors. Or these are instructors who said, oh, I want to go learn more about my class. I want to measure what I'm doing. This is an instructor who's pretty plugged in, right, to think about education. So they're not normal. A lot of them, in fact, almost all of them report using collaborative learning in their class. They're not just lecturing. And then many of them also use learning assistants, which are undergraduates who have helped transform undergraduate STEM classes to have a lot more small group discussion. So we need to limit our study thinking like, okay, our study applies to courses that are pretty engaging, pretty, are doing a lot of the things that as education researchers, we recommend instructors do, engaging their students in discussion. Yeah, so our data collection, and we've got Lasso. What's being administered on Lasso are these research-based assessments. My question to you all are, what are research-based assessments? Anybody have an idea? But the name gives a pretty good hint, but everyone take a crack at it? Sam, you got pointed at. Yeah, assessment-based research. Yeah, so really, right, there's a lot of assessments, like you come up with a final for your class, or you sit down and like, I'm gonna write all these questions. And that's great, but like, does it really measure the thing that you want it to be measuring? How do you know? What evidence supports that? So these are things that usually, like, somebody's dissertation was to design this assessment, and it's gone through a lot of work. So I'll give you 2 example questions. One of these comes from a chemistry one. The first one, it's about heat, like what is heat? The second one comes from a physics assessment. Person spinning in a circle, let's go of an object, what direction does it go in? They tend to be conceptual, not a lot of numbers. Like, do you understand the core concept in this discipline? And so I'm going to be looking at 3 different research-based assessments in this study. In chemistry, we've got the chemical concepts inventory, which is where that heat question came from. In biology, we've got introductory molecular and cell biology assessment. And in physics, it's the force concept inventory. The force concept inventory is probably the most administered research-based assessment out there. The one used in the most studies. It's led to a lot of change in physics courses. Like, it's been the core thing to provide evidence to say, oh, we should be transforming our courses to be taught in these other ways. So yeah, like I said, they're usually given like the first week of class, and again, the very last week of class to see like, where do we start? Where did we end? Okay, so with our data collection, we had a fair amount of data. You can see, right, roughly a little under 19,000 students, 44 different institutions, 305 courses across the 3 disciplines. We have student level data, which is their pre-test score, their post-test score, and their social identifiers, which they chose to identify however they wanted there. And then we also have some course level data. The important part of that for this study is just that most of these courses use collaborative learning. In fact, nearly all of them, well over 90%. So that's our data. I want to introduce an idea here that's going to be key to this study. And this is the idea of society's educational debts. Yes, question though, first. Yeah, so collaborative learning means not like a classroom like this, right? This classroom, like, I'm going to lecture at you. The time usually, and sometimes it's done in classrooms, but it's like you're going to have opportunities to turn, talk to your neighbor, and come up with ideas and share those out. And it's got students developing ideas as opposed to just being recipients of ideas from the instructor. And actually, I've got a slide I can show you more of a breakdown, like the things they report doing. Like, do they have small group discussions? Do they have, all these different things? And how often do they do them? And so they were categorized in that data. But good question. Thank you for asking. So society's educational debts. This is a key idea in this research. And so I want to lay it out. So assumption I have is that all groups of people are born with roughly the same potential on average. And this potential could be to do all sorts of things. Maybe it's to be a chef, or it's to do, like, imagine whatever you want on that y-axis. But I believe that all groups are born with that same potential on average. Any given individual might be, each dot would be an individual here, like have more aptitude for a thing, but in general, they're the same. This is where we begin. However, once a student comes into our class, let's say our physics classroom or our chemistry or biology classroom, and we give them a pretest and say, oh, where are you? Using the force concept inventory, what knowledge are you bringing in here? We see an inequity. And that difference in those 2 groups there, I'm going to refer to that as society's educational debt. Some might refer to that as a gap. But I'm not going to use that language because I want to make it clear where it comes from and whose job it is to fix. So the source of this is somehow we came from like, okay, everyone's kind of born the same. Now we see these differential outcomes. This can become due to a lot of things. These societal inequities, whether it's wealth, housing, food insecurity, your schooling, all of these things throughout these individuals' lives have led them to come to your class with different backgrounds, right? And we see these inequities at the beginning of our class. And by framing it as society's educational debt, I propose that it is society's duty to repay that debt. Society, through all these different forms, all these different systems, created this inequity, it's society's job to fix. It's not those individuals. It's not their fault. It's society's fault, and we need to fix it. So we then teach our class, and we give a post-test, and we can imagine 3 different kinds of outcomes. We can mitigate these inequities. And in fact, this would be a case where like, oh, here, society's educational debts are gone. At least on this measure, we're not seeing any evidence of any more educational debt being owed. This is like best case scenario. This is what we want. We can imagine another scenario where we perpetuate the inequity. So here on the post-test, the educational debt is the same. Everyone learned, and maybe they gained the same amount, but the educational debt we started with is the same as what we ended with. And I don't call this a win, although some have in their research, like, oh, everyone learned the same amount. But no, we just perpetuated the inequity. We let it carry forward. We didn't do any of our duty to repay that educational debt, if that's our outcome. Third, we can exacerbate the inequity. And here we say our educational debts get larger. This is, of course, the worst case scenario of these. So kind of these 3 kind of outcomes that we could imagine. And again, I think I assume we would all want to see this mitigate inequities where we're repaying society's educational debt. So this would be a key idea. This is the measure we're going to be looking at, is how much educational debt there is owed to these students in the research. So questions about this idea? Okay, sweet. So what are my research questions? I could have asked this question, but I'm not going to. The question I could have asked is, how large are underrepresented minorities' gaps in science knowledge? I'm not going to ask this question because this sounds like it's putting it like, what's wrong with these students? There's something wrong with them. And how wrong is it? Right? I don't want to measure how deficient these students are. No, that's not what I'm going to ask. What I'm going to ask, that's the way a lot of wording tends to be. This is where my conceptual framework drives me to ask this question a little differently. I'm going to ask 2 things. How much educational debt does society owe students due to racism, sexism, and classism before taking introductory college science courses? And to what extent do introductory college science courses mitigate, perpetuate, or exacerbate society's educational debts? And here you'll see, 1, I'm naming the source of these educational debts. I'm not going to say, oh, it's race, it's sex, and it's class. So they're like, oh, the problem is they're women. Like, no, that's not the problem. The problem is sexism exists, right? So I'm going to name these sources. And I'm not going to say these are gaps, right? It's not a problem with the student. It's a problem with society. It's educational debt. So I'm going to name those in there so that my findings hopefully can't be used to perpetuate the deficit language. Yes, please.
Maybe premature, but how are you going to address intersectionality in those questions?
That's a great question. So when we do our models, we're going to have actually, no, we're skipping the slide. I have an extra slide, so I'll say it really quickly because we're not gonna have time to do the full slide. But the idea is you're gonna have intersectional terms in your model. So you don't say like impact of sexism, impact of race. You have those 2 terms interacting as well. So it can make a separate prediction for Hispanic women that's separate from women, that's separate from Black women, that's separate from so they have more terms in the model. It uses up more degrees of freedom, requires more statistical power, but allows more nuance in the findings. Yeah.
I'm going to try to make this a small science question, but I did notice that sort of your tenets of the concrete theoretical framework leave out one of the tenets of critical race theory, which is sort of this action-oriented transformative next steps.
Yeah.
And I'm not seeing any research question that has to do what do we do with that?
Yeah, so I'd propose it's in the tenets in 2 potential places, especially in the first one, the centrality of oppression, and then it is the researcher's job to actively push back on that. That is a place that it shows up in the tenets. But you're right. So in this research, the data we have don't explicitly look at what is the solution. We draw on other people's research for that. Right. So a lot of times it's a piece of the puzzle, but it's certainly not the answer on its own. In the talk today, I'll offer a partial tool or a potential tool, but you're right, it is a limitation, and it's the thing we're striving for. And all the tenets, they're goals. They're aspirational, and we're going to do our best, but we won't always do all of them as well as we would like. But thank you. That's a good point. So I'll give you one other methods place here, and this is a paper. It's a paper I need to write. Nobody's written yet, but I want to think about modeling and where these tenets come into modeling. So in a traditional model, we'll take our data and we're like, cool, I'm going to make a model for my physics course. I'm going to make a model for my chemistry courses. I'm going to make a model for my biology courses. But all of these models, when you create a statistical model, there are two kind of underlying assumptions that can be in your model. You can either say, I have no idea what any of these coefficients should be. It's a completely uninformed model, or the model can start saying, I'm going to assume all of these coefficients are 0 until the data tells me otherwise. The problem is that actually directly contradicts both of those assumptions, directly contradict the number one tenet, which was oppression exists. Both of those assumptions do not have that baked in there. And so with Bayesian modeling, we can do something about this. Does anybody know what Bayesian priors are? Would you mind giving us take a shot at it here?
I come from like my framework of Bayesian.
Yeah. Yeah. So you can tell the model, here's my best guess. Now you can do that straight from like other studies have found this. So like, let's make this our starting place. And you tell, here's how confident I am, and here's where I think we start. So I told you in my tenets, I know racism, sexism, classism exists. I know inequity exists. So I should tell it that's where we should be starting from. Don't start assuming there's none. That's the antithesis of my conceptual framework. So I'm going to bring the centrality of oppression in here. I'm going to say, okay, I know there's inequity. And how am I going to tell it how much inequity I think exists before it looks at the data? Actually, we had an advantage. In the lasso data set, I grabbed data from another assessment, another physics assessment, the force and motion conceptual evaluation. Said, okay, let's analyze that. Let's see how much inequity is in there. And whatever that is, that's probably like a decent guess for how much inequity we're going to see in the next instrument. So we said, okay, we do this first model, and now we can bring in the prior, and we bring in our new data to develop our model of inequity using the FCI in physics. We used priors from that and new data for the biology one, as well as for the chemistry model. So we didn't start with the assumption of no inequity. Anyway, so this is a way that Bayesian modeling and quantitative or quant crit can speak to each other. All right. That's a little further in the weeds for some folks. Like, I don't know what Bayesian means. For our modeling, we created hierarchical linear models here as well. We had the pre-test and the post-test nested in students nested in courses. And I have one final methods thing before we actually get to look at some data here. I want to talk about model uncertainty. And we're going to imagine a scenario. Let's say on the way here, I stopped at the Phoenix airport. Let's pretend I stopped at the Las Vegas airport. And there's somebody set up. They've got a little table set up, and they've got two bets. They're like, please come bet, place one of these two bets. And it says, and the good news is I'm a quantitative researcher as well. I've been collecting data on these two bets. And so I can share some data with you. Here's the profit on the y-axis and bet one and bet two. And so for bet one, on average, you make $5. And maybe you make a couple dollars more, a couple dollars less, but it's pretty consistently around $5. Like, oh, this is a great bet, right? I'm likely to profit here. It's got these confidence intervals may range between $3 to $8. Like, great, I'm likely to make some money here. Said, bet number two, on average, you make $40. Sometimes you make as much as $80. Every now and then you'll lose $1 or two. Much larger than these confidence intervals are much larger. So me as a rational human being, which bet should I take? If I get to play this game once, I want to walk away with as much money as I can. What's the better bet? You're welcome to talk to a neighbor. Let's take 20 seconds, talk to a neighbor. What's the better bet? All right, so who here thinks I should take bet one? Who here thinks I should take bet two? I saw more hitting bet two. So I'll say bet two is the better bet, right? Like on average, I get $40. That's way better than on average $5. And you know what? Maybe I lost $1. I can live with that. I'd rather, maybe I'm gonna make $80, right? Like bet two, if you got to bet over and over and over, you become much richer betting bet two repeatedly than bet one. So, right, which bet should I take? Bet two is the right one. But now, what I want to publish on this, I'm gonna put my stats hat on and be like, bet one has a p-value. This is very likely to be greater than 0. P is less than 0.05. But bet two, that could in fact be 0 or get less than 0. P is greater than 0.05. And so if I'm going to publish them, it's like, bet two, we're going to pretend that's 0. That's not like, it's the better bet. We're like, this is nonsensical to say, any p-value greater than 0.05, let's pretend it's 0. That doesn't make any sense, right? Like that's not rational. It's not what the developers of the p-value ever wanted to be used as. It's not what the American Statistics Association says we should be doing. They say, please stop doing that, everybody, in all fields, not just education. So this is a choice that gets made all the time to treat p-values this way. But it's even worse when we think about equity. Let's say instead of this profit, let's say this is educational debt. And I've got group one and group two here. I'm like, oh yeah, group one's owed educational debt. Group two, we didn't have very many of them study. No, they're not owed anything. It's fine, they're fine. No inequity for group two. That's ridiculous, right? Like there's this huge inequity. And yeah, maybe it ranges, like there's some chance it's 0, but it's much more likely in fact group two is owed a larger educational debt than group one. So to call that 0 is really problematic. So if we're using this like p-value go no go test, there's a strong incentive to aggregate as much as possible. I want big groups, so I got small error bars, small p-values. And sure, I do want small error bars in my work, but if I'm aggregating everything, I'm losing all the intersectionality. I want to see what all these different groups are doing. If I lump them all together and be like, just URM. Now I got a bunch of URM students, underrepresented minorities. Sure, I'll get a small p-value, but like I've lost all my intersectionality. And it obscures inequities. I can point to plenty of papers where people have said, do I have equity between gender in my class, my physics class? And so they say, well, okay, how do men do on the final? How do women do on the final? Run a t-test between these two groups. P was greater than 0.05. These groups must have been the same. We're going to say the difference is 0. But like, no, the women, like, look at the numbers. The women are not scoring as well. They're not being served as well in this course. Just because you only had a couple women in your course meant you had a large p-value, and you cannot claim equity there, right? Your data says there is an inequity, and you're sweeping under the carpet, and you're claiming, my class is great, just because you had a small number of women. So really problematic inequity work. Okay. Let's get to actually looking at some data now. Let's answer some research questions. So we're going to start in physics. And on my y-axis here, I have educational debt. And as a reminder, educational debt is, in this case, it'll be the difference between white continuing generation men's scores and whatever comparison group, whatever minoritized group is there. So it's the difference between their scores that we're going to be looking at. This is part of me speaking for the data. This is the thing we're looking at, educational debt. And on the y-axis, we got all these different groups. So I'm going to show you just a little bit of data here. For starters, talk to your neighbor. Actually, I'll give you a little heads up. So we have Asian students. This is our first gen women in green, our first gen men in blue. So first gen Asian women, first gen Asian men. And we have their pre-test and their post-test. This is the amount of educational debt they were owed at those 2 snapshots in time. Talk to your neighbor, see if you can make sense. Like, wait, what is this telling us here? We need to make sure we can understand what it means to be an educational debt. I'll give you 30 seconds to try to make sense of what you're seeing so far. Anybody willing to try and interpret any of this for us? You don't explain all of it, but even just a piece of it. What are we seeing here? What does it say? Give us, interpret any of it, if you can. If you're willing to take a shot, somebody. Yeah, what do we see?
So the women's educational debt is going down.
Yeah, from pre-test to post-test, it got smaller.
Right.
Yes.
The men's educational debt is staying the same.
Yep.
The women still have more educational debt than the men.
Yeah. Yes, excellent. And so just a reminder, this is basically saying, like, to start, women, Asian, first gen Asian women scored roughly 13 percentage points lower on the FCI, that's the measure we use here, than continuing gen white men. So that's their education that was around 13. On the post-test, it was 10, 11 points lower. Yeah, so a little bit of repayment of educational debt, right? We see the women were, the first gen Asian women were owed a larger education than first gen men. Asian men. Questions before I show you all the rest of the data? Yes.
How do you incorporate the uncertainty into your results, because there's no change?
Yes, so right. So uncertainty is pretty large here. Great question. Let me show you the rest, and then then we'll address that. It's a good question. Because you're right. If this was all I had, I'd be like, yeah, I'm not real confident of that. I agree. Okay. So here's the rest of it. Take a minute, talk with your neighbors. What do you notice? There's a lot here. I'm going to give you a minute. Anybody willing to share something they might have noticed? Yeah. So white women, right? We see like a lot of educational debt being repaid to white women. These are dropping quite a bit. Yeah, and so getting to this idea of uncertainty, if all I had was this thing right here, I would be like, it's probably dropping. There's enough uncertainty, like maybe it's not. I'm not as confident. But when I see it here and I see it here, so then, oh, I'm a little more confident now, right? I see continuing gen and first gen, very similar signals. We can start to look in aggregate. Like, do we see consistent trends? It's part of how we deal with this uncertainty, which I can point to more things in a minute. But yeah, other things folks noticed.
Well, conversely, Hispanic men and women, very little to actually increase in education debts.
This is like really flat, right? For all four of those groups. Any one of these, right? We see like a consistent trend. Okay, this is pretty flat for our Hispanic students. Also for some down for our white Hispanic, but you know, these groups have some similarities. What else do we notice? Yeah, right. There's one group that goes up a lot. Our first gen Black men are being served very poorly in these courses. Yeah.
It's better to be a man.
Right. So like, super consistent signal, right? In every single case, there's only one dot on here where it's better to be or where women are owed less education than men, and that's on the post-test, first gen Black women. Every single other one, women are owed larger educational debts. So again, with any one of these, you know, you might not be 100% certain due to the error bars, but that's a pretty consistent signal. Okay, other things we notice here?
First gen white men. The educational debt is really close to zero.
Yeah, so these are pretty close to zero, right? So first gen, and one thing I think we notice in general is the difference between first gen and continuing gen. There's differences, but it's not huge. It is consistently worse for first gen students, but not as big as like the inequities due to sexism. Like those are much larger inequities. Okay, so yeah, please.
Sorry, you might have answered previously, but how do you determine the starting point for all these?
Yeah, so this is it's in compare, the one group that's missing here is our continuing gen white men, because they are the reference. So it's them compared to that. Yeah. And so right, it's just like before class, before the first week of class, after the last week. So I'll point out some things here. I'll also contextualize this. The average gain from pre-test to post-test is about 20%. So you think like 20% is a semester's worth of learning. So when we see these pre-existing educational debts ranging from 1 to 20%, with a mean of 12%, that tells us the average educational debt was about 2/3 of a semester's worth of learning. That's quite a lot, right? Like that's not trivial. Is that a meaningful amount? Absolutely yes. And for some groups, it's like a full semester. You got to take a whole semester of the class before you even get to where continuing gen white men started the class. Okay. So, I also look at these, right? There's some of these lines went up, some went down. In general, they're more flat. I would say this is a perpetuation of educational debts, right? The educational debts increased for 7 of the 19 groups, had a slope up. That means 12 of the 19 were down. Average change of negative 0.6%. So we went down, but that's not, you know, if we had an average of 12% educational debt to pay and we paid 0.5%, this is mostly maintaining or perpetuating. It's pretty flat, right? So they're coming in, owe the same educational, or leave being owed the same educational debt they began. Yes.
I mean, if this were data that I was working with in my own science,
Yeah.
I would be drawing straight lines for everything, saying there's no change because of the uncertainties. You said you were going to get to that.
Well, so that's what I talked about. So part of that answer is the consistency of the signal. Well, one, you compare to group you want. If I want to compare this group versus that group, like it's clearly different. This allows you to make any comparison you want. But again, consistency of signal. Every single group of women is owed an educational debt larger than every single group of men. Oh, for the same. Now, within any one of those, the error bars could totally overlap, right? P-value is greater than 0.05, but I see a consistent signal. So that's part of the Bayesian-like interpretation of it. And in the paper, we'll make some claims strong others. Like this is like a really clear one. This one, the uncertainty is larger on it. It appears that this is happening, but we're not going to make as strong of a claim. All right, but we have more consistency of signal still. Well, we'll have some similarities and differences. Take a moment. We're going to look at the chemistry data. Make a prediction. How do you think it's going to compare? Anybody willing to share a quick prediction? Doesn't have to be right. I'm just curious what y'all think. Yeah.
I think both will be better.
The chemistry will do better than physics?
Yeah, there will be less education.
Okay, less educational debt? Let's find out. So for context on this assessment, the mean gain is around 9%. So this is about a semester's worth of learning right here. Take you a moment. What do you talking to your peers? What do you notice? What's that? It's everybody. How much in average on that class from pre-test to post-test? How much did they score higher on the post-test? Only 9% on this, right? They didn't gain a lot. It's a difficult test to gain on. So what do folks notice here?
Minus groups that are,
Yeah, we got some groups into the negative values here. So our agents, there's another consistent signal, right, that kind of goes with that. What is the slope of all these? Yeah, they're all down. As this comes back to our uncertainty, take a group, for example, like how certain am I that this group went down? If that's all I knew, like, well, there's certainly, like, I'm not 100% certain. But when I see it in 19 of 19 cases, I become pretty confident that, okay, there is in fact educational debt being repaid here. And makes me confident for any of them, such a consistent signal. So some things I see, right, so our mean gain for context was 9%. That initial range is 1 to 15% with a mean of 9. On average, students are owed an entire semester's worth of learning to begin that class. It takes a whole semester to catch up to where the continuing gen white men began. That is huge amount of educational debt. That's the bad news. The good news is it does appear to be mitigating in these courses. These educational debts increased, yeah, for 0 of them. They decreased for all of them. And with a mean change of 4.1%, that's a meaningful difference, right? If the semester's worth of learning is 9%, they got almost half that back. So there's some good and some bad here. Much larger initial educational debts, but a positive change. All right, let's do biology. Take a moment, you make your predictions about biology. All right, looking at biology, here's what we get. You chat with your judges. Mean gain is 15% for this. So this is right, average gain for class, about a semester's worth of learning right here. There's good news and bad news here again. Anyone want to share something they notice? So Marty, you want to say what you said to everybody?
I would say they're biology class is not good.
Right. So women again are owed larger educational debts than men. I believe in every case again. Yep, pre and post. And women make up 60% of our biology courses. And right, what happens to their educational debt? Especially for the women. The only groups that get better, there's a couple that get better, they're all men. So we like to think of biology classes, this is gonna be our chance to do good. Yeah. Different students. Yep. So yeah, so what do I see here? Again, our mean gain is around 15%. This initial pre-existing educational debt. Oh yeah, question.
Have you considered the fact that there are more women in bio classes than physics? So the gender distribution has changed radically.
Yeah, so in our physics students, women make about 20% of the students. In chemistry, they make up 50%. In biology, they make up 60%. And then in the discussion that comes up. But this is where we thought biology was our best chance to do right by women.
But you have more women, and so the spread of aptitudes, etc., is going to be larger.
Sure. I mean, no, not the spread within the data set. You will get a larger range, but student by student, in the population, you would expect it to be the same. But more data would shrink your error bars there, even anyways. So they're initially owed much less, right? Initially, this looks pretty good. I mean, relatively good. They're still owed a third of a semester, right? That's not good news. That's bad news, but it's better than in biology or chemistry. Yes.
What could be a problem, the underlying part of that human right?
So this is absolutely driven by also, a huge part of it is how well are continuing gen white men served, right? It's in comparison to that group. So it's not saying, I mean, all of the groups are learning. They're all doing better on average on their post-test than their pre-test. However, are they learning as much as our group with the most advantage? And are we seeing these debts get larger? Because honestly, it matters how you do compared to your peers, right? It's not like because when you look for a job, when you look for a graduate degree, you're going to be compared to those around you. And so I certainly want in my class, I want to repay some of the educational debt. Well, I want to make sure we have time to get through a couple more things here. So in here, we see educational debt increases for 16 of the 19 groups, on average by 2.5%. So again, any one of those, I might not be real confident, but when I see such a consistent signal, I become more confident that there really is an effect here. So what do we see across these? Some similarities, some commonalities. The largest debts were owed to Black and Hispanic women and first-gen Black men in all three disciplines. So there's another consistent signal. We see it repeated. Some things that we see different is biology starts low, but exacerbates the educational debts. Chemistry started high, but repaid some of those educational debts. Some of our takeaways here. What do I take away from this? First, racist, sexist, and classist power structures impact our science classes. Whether I know we desperately want, like, there's no culture of science, and whatever happens out in the world, like this is like my safe place, but it comes in and it gets replicated in here. So we have to be thoughtful about these. We can't pretend it doesn't exist. And using collaborative learning is not enough. I think it's a great first step. We should all be doing it. But just doing that, all these classes, or nearly all these classes are doing it, and it's not like we see all these educational debts getting repaid. Although I will say we have other studies where we looked at the impact of using learning assistants to change these classes, and we do see a lot more equity in course failure rates. So I do think this is a lot better than lecturing, but it's like we need to dig deeper. We need to do more. Equitable gender representation is also not enough, right? We saw that women are even overrepresented in biology, and we saw the education that's owed to them get worse. So just gender representation is not enough either. We got to do more. Universities, departments, and instructors must work to repay these educational debts or become complicit in them. My takeaway. You don't have to agree, but so in our how much time? Okay, I want to quickly share a potential tool, something we're working on right now that we hope can help. We hope this will help in a lot of ways, but what's a potential way to broaden participation? Well, one thing we've learned in some of our studies is these educational debts are not evenly distributed across all the skills and content areas. So for example, in physics, we see a large educational debt being owed around Newton's first and second law. So our continuing gen white men come in with a lot more knowledge about Newton's first and second law than other groups, but they don't tend to come in with a lot more knowledge about Newton's third law or superposition of forces. So if we want to help level the playing field, if we can identify where these educational debts are and hone in on those, we can make it better. However, if we say, oh, my average student is doing just fine on Newton's first and second law, let's move on. Well, your average student is, especially in a physics class, is more likely to be a white continuing generation man. And so if we say, oh, okay, great, we're going to move on, we're not going to spend as much time on Newton's first and second law, we're probably going to make these inequities worse. So we may skip covering these critical underlying skills, thereby exacerbating inequities. So something that might help is we're developing something called a cognitive diagnostic. And so it starts with a computerized adaptive test where you have some question. If you get it right, you get a harder second question. If you get it wrong, you get an easier second question. We're kind of used to that. It kind of keeps going till the end. But the cognitive diagnostic has another thing layered in here. There's an important difference. It looks at skill level mastery. So for any given item, it says, what skills do you need to have mastered to get it correct? So maybe for this question, you need to understand vectors and interpreting graphs. And if you know those, you're likely to get it right. So our AI algorithm that's presenting questions is also looking at the underlying skills a student is likely to have mastered or not. Let us say like, okay, where are they struggling? What, for each individual student, what skills have they mastered? What have they not? And it can give a report to instructors to hopefully individualize this more. So, okay, you know what your students need with these interactive reports that that focus on equity as well as a bunch of other things. And we're also hopefully going to be developing supports within the system for students like, oh, they haven't mastered vectors yet. Here's things to support them. But empowering instructors to find these differences and help ameliorate them. We're going to be looking at chemistry, biology, math going forward, and also extending to K-16 grades. But this is something we're working on right now. We hope it can help. But with that, I want to say thank you, and we have like 2 minutes for questions. Yeah.
So this is all very focused on the control of the class. So we talked a little bit about this, but do you follow how this gets like grows or shrinks into like upper level classes?
We have looked at second semester physics. Started to do that analysis, but had to put it on the shelf because other things came up. But it is a thing we want to do. One issue is most of these research-based assessments focus on intro. So we actually have pretty good data for second semester physics. We don't have as much data. It doesn't get smaller pools of students. So especially wanting to disaggregate with all these groups, you need quite a bit of data. So it's something we want to continue to do as our data set grows. But yeah, it's kind of future research. Yeah.
For you to collect any data on Indigenous students, do you have plans to do that?
No, so we do. The racial and ethnic categories we have there were the groups we had enough data, but as that pool grows, we can do more. Also, there's another modeling technique that we have a paper that's just accepted that lets such things to aggregate further. And so looking at non-binary students, like oh, all of a sudden it looks like we get down to a smaller cell sample, and we see these groups now meeting that minimum we need to represent them in the model. So that is also a thing that we are excited to do. Yeah.
This probably isn't available to data sets, but there is a fair amount of research showing that like in collaborative groups, there are gender dynamics.
Yep.
So it'd be interesting to see what the effect is as the the students are self-selecting to groups or person decide with the gender composition.
Yeah.
Or racial composition too.
No, I absolutely agree. Yeah, I know folks who have do that work and shows that like, right, we see these same power structures get replicated within the small group, which makes sense, right? That's the way I've been turned like by society. I should speak up because I'm a white guy, like, and nobody looks weird at me when I do it. So I get in a group, I'm like, oh, let me lead things because I've been trained to do it. So of course it gets replicated. We don't have the data for that. There are people looking at it. It's a really interesting question about how do we create the groups to do better and create group rules and things. Yeah.
It's a challenge.
Right, exactly. How do we take collaborative learning, which we know leads to more learning in general, and also make it more effective? Yeah, there's a hand in the back that no?
I did not. I was really curious about what that. How many?
For this analysis, we need a minimum cell size of 20 is what we want. So if we have at least 20 people from a group, it looks like using a method called MIDA, we might break it down to like 5. But there's still going to be a lot of question marks. Like we don't want to make any strong claims with that small sample size, but it doesn't mean we can't say anything. So that's probably the uncertainty. It's not just like it's true or it's not, right? There's a lot of gray, and we live in that gray and make stronger or weaker claims around that. Yeah.
I know you mentioned how many students.
Yeah.
How many institutions do you have?
So this is 44 in this data set across the 3 disciplines. So any faculty member can decide they want to do it. Yep.
Trying to volunteer.
Yeah, that's fantastic. We would love for entire departments to come on, because right now we have this bias, right? Like the faculty member wants to do it. That's a particular kind of faculty member. If we get entire departments doing, we'll get more distribution around faculty who do more lecture, who do like, so for research purposes, that'll be really useful. Yeah, you get a question.
For the skills that you identified or the lack of skills, do you or would you provide that information to the individual students so that they can attempt to address it? Because a faculty member can't spend a month on.
Right. So we're developing instructor for like class level courses, how's your class in general, instructor student level reports, they look at each student and student reports for themselves. Yep, so everybody can be like, here's what you need to work on, you know, yeah, all of that. And that's the thing we're currently developing now. Yeah, good question.
Have you or anyone else that you're aware of looked at trend having to do with class sizes, like smaller class?
We have looked at that a while back, and we didn't see any strong signals, at least around overall learning. I don't think we looked at issues of equity with that. That was quite a while ago too. But that data's in there. This data is for researchers. Y'all come get at it and answer that question. Like, we want people to come use it. It is a resource for the community. Other questions? Yeah.
So do you have studies that is available data set?
Yep.
Anonymized.
Yeah, so we anonymize it so you can't figure out who's who, but then we make it available to researchers. Yeah, with the goal of promoting all sorts of different kinds of research. That's part of what NSF pays for. You know, for us to develop this research database. We're right now being considered for a mid-scale research infrastructure, which would be a lot of money and allow us to really build it out as like, hey, educators, come get this data across K-16 grade bands, across all these disciplines, you know, track people over time. Yeah.
So with that data set, what kind of institutional data is there? Should be like tribal colleges and universities?
Yep. So I have a slide on this. Oh, it's not in here. Okay, but it's in the paper. But yeah, we yes, the college type is in there. So in this data set, it is we have a couple 2-year, I think we might have like 1 or 2 2-year colleges. We have some minority serving institutions, but it is much more heavily research intensive institution. Yeah. But that's an important, right? Like, that's really important.
Yeah.
One of the things we're really figuring out, like, how do we reach out to your colleges to get them to use these tools? Yeah. I know, I'm over time. You're welcome to hang out. Thank you.